Good evening, good afternoon to all of you. Welcome you guys. Welcome you all. How you are doing, everybody? I think we are live. First of all, you do check this thing here. Is the audio videos clear to everybody? Do check for this audio videos clear. Yes, I think we are live. Yes, do comment करके बोलिए now here. Is everything is fine? Tell me now here first of all. Yeah, chalo. Okay, so the further things now here, as you might be know, the climate is very bad because of that. So I'm not feeling well, इसलिए so I'm not able to take the classes. Okay, so we'll continue the classes and we'll try to cover this. We'll try to cover we'll try to finish the digital topic आज complete करने के लिए हम कोशिश करेगा. ठीक है? ठीक है. चलिए. Yeah, सबसे पहले so you can see now here the great news from Unacademy. So you will get the flat 60% of discount आपको मिलने का chances है. So never miss this opportunity before going to expire. The offer ends by tomorrow only. So that is 12 months के लिए just 9999. So you can plan it by using the code of BVREDDY. Use the code of BVREDDY and to avail the great opportunities. ठीक है? Now we started the Unacademy special class festival, that is from 3rd to 5th January. So you can enroll for these classes. And the test, so these are the ESC 2025 rankers from Unacademy team. So these are the ESC 2025 rankers from Unacademy team. You can have a look at. Now this year we have planned greatly. So already test series which is live, test series which is started from December 15th onwards for 2026-2027 के लिए शुरू हो गया. And we started the new batches. You can have a look at now here. The new batches is running and utilize them. You can have a look at for the 2028 के लिए and 27 के लिए भी हमने शुरू किया. Unacademy starter kit which is available in the exclusively Unacademy stores में available हुआ होगा. So you can see now we started the West Bengal electricity department का batch भी हमने launch किया. So you can, the student who are willing for it, you can enroll for it. You can use the code of BVREDDY and to get the personalized guidance from me. Crash course also we started. So you can see, might be know, test series which is free to all the subscribe student. The student who has taken an Unacademy subscription, for them test series is free. Unacademy test series we are providing free of cost. Including the test series you are taking the subscriptions. Unacademy Una. So with this there are the 3 different type of modes are there: voice mode, quiz mode, smart summaries. Right. So we are offering the two type of subscriptions. That is, one is Plus Wala, the other one is Iconic. Plus में India's top educators classes मिलेगा, live doubts, evaluated main test series, structured courses, PDF, live quiz, unlimited access. इसके साथ here Iconic में क्या मिलेगा? पर्सनल कोच भी मिलेगा एंड 1-to-1 फिजिकल नोट्स भी मिलेगा आपको. राइट. You can start a serious preparation with Unacademy to achieve your dream goals. We are there to provide you the best knowledge. And these are the small examples of GATE 2025 rankers from the Unacademy team. ठीक है, चलिए. So let's continue. So previously we have completed the flip-flops we have discussed now. And today we'll discuss about the registers and counters हम discuss करेगा. ठीक है, registers and counters हम discuss करेगा. Take down shift registers. Register का मतलब is what? Tell me now here. The one which will store the information. Information will store, that is called as a register. So like आपका copy, your notebook, whatever you have written, that will be there permanently, right? That is called it as, we can call them as register. Fine. Now, so whatever the data we have entered, the same data is there inside forever, isn't it? And whenever we need, now we have to retrieve the data, we need for the reading the data. So that's the reason we are using the one special flip-flop that is called as a D flip-flop. What the D flip-flop is? Characteristic equation Q plus is equal to D only now. Whatever we have entered, same thing will come as output, isn't it? That's why we use a D flip-flop we use in this case. And in this case, each flip-flop can able to store the 1 bit of data. If I want to store the more number of information, then I will combine those all the flip-flops together to get the required result. Right. And flip-flop is a single bit memory element. It can store only 1 bit of information can store, which cannot store the multiple bits at a time. So what we do here, we combine the number of flip-flops of the resultant circuit can serve this purpose, which is known as what? I'll be now shift register. Okay. And since no data manipulation is required, so we prefer D flip-flop for this purpose, isn't it? And you may ask, so the only D flip-flops are. Now you can see now, here we have, and we add this clock also. So is it fine now? Tell me, check करके बोलिए. So might be some network issue, I think so. Now, so take this thing here, clock. Now, so which we can write it as what? I'll now A, B, C, D. Okay. Now initially all the flip-flop inputs they given us what, tell me? Initially all the flip-flop inputs which is given as 1, 1, 1, sorry, this is 0 and this is 1. Now, so let's see this thing, how many clocks required to get this signal. So let us say first clock when you apply. So here, what is this one here? Input. Now here Dn, what should be? Dn is equal to A XOR with what element of D na? Now let's simplify it now. A XOR with D. Now first clock when you apply, so this means, and this XOR between these two now here, so will come it as XOR is what element of 0. 0 will come here. Now this will be shifted here, this 1 will be shifted here, 0 will come here, isn't it? Now you tell me now here, when you apply second clock, see what happens now. XOR is 0, 0, 1, 1. And when you apply third clock, so this is 1, 0, 0, 1. And fourth clock, 0, 1, 0, 0. And the fifth clock, 0, 0, 1, 0. Initial values they given na, this much 1, 1, 0, 1 initial value. Now sixth clock, which is equal to 0, 0, 0, 1. And seventh clock, so this is 1, 0, 0, 0. Eighth clock, 1, 1, 0, 0. Ninth clock, 1, 1, 1, 0. 10th clock, that is 1, 1, 1, 1. So here they are asking how many clocks required to get this result now. How many clocks you tell me now? How many clocks we got here to tell me now? After 10 clocks we got this result now. So the number of clocks required, how many we can say now? Tell me now. 10 clocks. Right? Next, see this next problem on these registers. The shift register shown in figure is initially loaded with the bit pattern 1010, that is initial values. Subsequently, the shift register is clocked, and with each clock the pattern gets shifts by 1 bit position to the right. With each shift the bit in the serial input is pushed to the leftmost MSB. After how many clocks will the content of the shift register becomes 1010 again? How many clocks? कितना clocks होने के बाद? So then the result again come back to 1010. Yeah, try it. How many clocks we require? Now you can see now what is the input here. So I'm naming this thing. Let us say this is A, B, C, D. I'm calling. So this is A, B, C, D. Now what is the input? You tell me now. Input which is equal to XOR between, here this is C XOR with D, and that is what I am now, B XOR with C XOR with D. So this is what I am now, B XOR with C XOR with D. Okay. Now let's talk about the initial values given of what, tell me now. That is 1 0 1 0. Now you tell me now, when you apply the first clock, so what is the input? Tell me now. XOR between what? Tell me now. B, C, D. XOR. So for odd number of ones, it is 1. So here odd numbers only now. So input is 1. That 1 will be shifted to here A now. 1, 0, 1. Second clock, input is XOR. So that is 0, 0, 1, 1, 0. And third clock, input is 0, 0, 0, 1, 1. Fourth clock, 0, 0, 0, 0, 1. And fifth clock, that is 1, 1, 0, 0, 0. Sixth clock, so 0, 0, 1, 0, 0. Seventh clock, 1, 1, 0, 1, 0. Yes, that's what we need now, tell me. And what we need now here, this is 1, 0, 1, 0. After how many clocks we got, you tell me now? 7 clocks. So that means what the answer, you tell me now? 7 clocks. Okay. Next one. And take this problem. So an 8-bit register is made of 4-bit PISO register cascaded with a 4-bit SIPO register as shown in figure. The total number of clock pulses required to perform the write and read operations. How many clocks required, they are asking to find. So you can tell me now. So we need to do this complete read and write operation for the 8-bit of data. Okay, so this is, here you can see now they're given. So first one is what, tell me now, this is a, so this is PISO register. This is a PISO register, this part. Parallel in serial out. And this is given as SIPO register. Serial in parallel out. Right. So that means first of all, totally we have 8-bit of data is there. Consider the 8-bit of data. Let us say this is, we have A, B, C, D. And we have this as X. Okay, we consider this as W, X, Y, Z. This is the data we have. Okay. Now this 8-bit of data we need to enter and we need to take the output now here. Now here first what I can place now here. So then Keval, this is the entrance first. So that should be initially W, X, Y, Z I given. Now this data. So what should be the condition when this data will be entered into the register, you tell me. So here tell me now when it is happens now here, that is to load the data. To load the data into which register this is? PISO. To load the data into PISO. You tell me now how many clocks required, you tell me now. Number of clocks required. This is PISO na? And this is SIPO. So that means all the inputs are available. If we apply one clock, then complete data will be entered into the register. That is only one clock is enough now. If we apply one clock, so after one clock, this is the situation. W, X, Y, Z will come here. Okay. Now, what I need to do here, this data, so should be shifted to this one. To shift it now, first when you apply one clock pulse, this Z will be shifted to here. Okay. Next clock pulse, Z will be shifted to here. And then Y will be shifted to here. Next X will come, next W. So how many clocks required to shift this complete data into in this register, you tell me? इसमें shift करने के लिए how many clocks required, you tell me? W, X, Y, Z. I need to shift the data completely. यहाँ से इधर shift करना. Now it is empty ना? Now you tell me now here the conditions. What we can say now here, to shift the data. To shift the data from PISO to SIPO. I need to shift to SIPO. How many clocks required? You tell me now. 4 clocks required. Is that no? All the one by one, we need to shift it. Okay. Now here this is loaded. Now I need to load this thing now. Now I given the inputs are given as what I know, A, B, C, D I given. Now again I need to show to load it. So tell me now here to load the data into which one? PISO second time. So how many clocks required? 1. So totally this is what will be, this is called as a. So now A, B, C, D is loaded. So all the 8 bits of data is loaded into my register. This is called as a write operations. So loading is completed. Now I need to take the output we need to take now, that is called as a read operations. Tell me now for to read the data. So you can see now here where the outputs are available. This is only the outputs here. Here only outputs are available, isn't it? Now here this data which is readily available at the outputs. So we no need to apply any clocks now here, isn't it? Now first of all what we can say now here in this case, to read the data, we can say to read the data from where? SIPO. How many clocks required now here? No need of any clocks since those are readily available at the output location only now. So no clocks are required. Now this is taken outputs. Now yes, now to take the outputs, now all this data I need to shift to here. Now again to shift the data from PISO to SIPO. How many clocks required now? 4 required. Once A, B, C, D shifted here, that means so here this data which is readily available at the output location only now. So that means how many clocks required? No need of any clocks. So then this is for the read operations. Now totally how many clocks required, you tell me now? Total number of clocks. How many clocks we can say now? 6 plus 4, which is equal to 10 clocks are required. Understood this point? Tell me. Good problem. This type of problems will come on from the registers. Here, this A is there now here. So this is readily available at the here. This is the output now. By taking a while, we can take this thing. Okay, so this E is there here. So if we by connecting the while, we can take the output now. That is, isn't it? When you apply one more clock apply किया तो क्या होगा? One more operation shift करेगा. Isn't it? The data is disturbed. This fellow, this A, which is available at the readily available at the output terminals only, na. So B also available at the output terminals. C also available at the output terminals. D also available at the output terminals. Yes. Now fine. Complete. We need to explain. Yes. Did you understand this up to the right operation? Tell me. Up to the right operation you understood or not? Tell me. And tell me now where you have a problem. You tell me now full you have problem. For easy understanding purpose, let us consider it is 4 bit of data. 4 bit of data we'll consider. 4 bit of data we'll consider. Now let us say this is my clock, and so we have this is, I'm calling this as Q3, Q2, Q1 and Q0. Let us say I need to load the W, X, Y, Z. I need to load the data. You tell me now what the process we should do here. And so first I given the input, I given this as Z I given. First when you apply initially all the flip-flop values are zeros now. And here you see the input. I given first Z given. Z I given. I apply the first clock. Then what happens now? The Z will come here now. Now this is 0, 0, 0. Isn't it? This is shifted to here. And this is shifted to here. This is shifted to here. And this bit will is lost. Okay. Next, I given the input of Y I given Y. So when you apply second clock, then what happens now here? Y will come here. This is Z and this is 0 and 0 will come here. And this shifting will come like this. And now this bit is lost. Next, now I given this X I given third clock when you apply. Then what happens now? X, Y, Z and this is 0. Now this bit is lost. Okay. And I given this W given. So fourth clock when you apply, then what happens now here? W, X, Y, Z. This process will continue like this now. Now here, now the fourth bit of data is loaded. Okay, now I need to take the output, I need to take now here. So you tell me now here, when we apply, you have given some randomly, you have given something, when you apply first clock pulse, what happens? Yes, what some randomly you have given something, don't care. So then don't care will come, this is W, this is X, and this is Y. Then see what happens now. Now the Z bit will lost or not, you tell me. Z will lost. Understood what I am saying here? So here, now that means what we need to do here, before applying this next clock, we should take the output Z value to be taken as output. Otherwise, the Z bit will lost completely. Isn't it? Why it is happening now here? Since the Z is available at the output location. Directly we have to take the output now before applying a clock pulse. Understood this thing? Everybody tell me. The same concept here. और देख के बोलना here फिर भी doubt है तो बोलिए now. Should I explain this thing again? अगर आपको मजा आए तो दिल बना लो. Done everybody? चलो अगला सवाल. Take this one. Consider a serial in parallel out register they given. The right shift circuit with the initial content is given as this much as shown the figure. The circuit is operated with a positive edge triggered clock signal as given below. If plus 5 volts and 0 volts are used to represent logic 1, logic 0. So here, at which of the following instance the LED is in on state? LED on state. LED on means the output Y must be 1 we need to have, isn't it? Output Y is 1, so that means this is 1. If this is 1, then only LED on karega. If this is 1, AND gate na, both inputs are 1, 1 hona padega. So that means this value, this is 1. Okay, and that means this input must be also 1. And we need to check when this will be 1 hoga. Right? Now let's form a tabular form here. Clock, time, and this ABCD. So this I am calling it as clock, and this is time, and this is A, B, C, D, E. Right. Initially, the given content is given as what is known 0, 1, 0, 1, 0. Okay, fine. Now, when the first clock is applied, you see this thing here. How much the clock, what they given now here? So you see this thing, look at now from this time period of a clock signal, positive edge trigger. Now these are clocks are applied like this. Time period is how much now? 20 nanoseconds. When the first clock is there, you tell me now first clock in between when t is equal to 0 and here t is equal to 20. So that means what we can in between 0 to 20 nanoseconds, first clock is applied. And so you see this thing, what is this thing here? We have taken as A, B, C, D, E we have taken. This output is P. Then this is what is 1, 0, 1, 0, 0. Check this thing all of you. Now in this case you see this thing here. Is it? Now here when the first time period of a clock signal, if this is 0, 0, so here and this is whatever 20 now. The time period of a clock signal is how much? You tell me first of all 20 nanoseconds. Okay, now when the first clock is given 0 to 20 nanoseconds, so this means then E, this last bit will come to the first bit, and again it will be shifting will takes place now, circular shift. So that's why this 0 will come to here. Now this will be shifted here now like this. This you understood now first of all. Next, when the second clock will go 20 to 40, in between 20 to 40 we have this thing 1, 0, last bit will come to front bit now, first bit, and there is a shifting is taken place. Okay, so here this bit will came here and this bit will came here and this bit came here like this. Next here like this shifted. There is a shifting. Okay, the shifting is taken place, you see. Okay, the last bit will come to front bit, first bit. Okay, done. Now you tell me now here for this LED to on, so here this must be a 1, this is 0 now. C must be a 1. So you see this thing C is 1, E is 0 now here in this case. Which interval now here in between 60 to 80 only, this is on state. This is 60. Sorry, this is 60. Okay, do correct it. 60 to 80 in the interval, this is on state mein hoga. Isn't it? Okay. Next. Chalo, now we'll move to the next one, that is a counters. Counters. Another बढ़िया topic है counters. Listen carefully. Counters, here also we use a combination of flip-flops we use that will generate the desired counting patterns. And totally counters has been classified into like this. You can have a look at now. counters are classified into two categories, that is asynchronous parity bit hazards concept. Parity bit hazards are deleted actually. So hazards that was there very long back is there. Okay. So now there the topic is not there, not required for the gate syllabus. Parity also not required, don't worry. And we'll try to cover maximum, we'll try to cover. If it is anything is left and we'll do in next class, we'll do. And but we'll try to cover the maximum, we'll try to cover in this class. Logic families, that is the where that weightage of this topic is very less here. Logic families you want. Logic families, that is weightage is very less. Almost they won't give it is logic family. That is important for ESC, but not for gate. Logic families. Kabhi time they are giving the problems on the data converters, but they are never giving the logic families. Okay, they are giving the problems from the data converters. Sometimes they used to give, but never given the this thing. And so after that we have another session also will plan. So one short session is there. One short session will plan. One short session will plan, and that time also will cover the maximum topics will cover. Hmm. Okay, then we'll plan the one short session. We'll plan the remain if there is the most important topics we'll do. One day we can do it is we'll cover them. And so then data converters will discuss. Logic family is not required here. K-map also. Okay, K-map also will do then. Fine. Hmm. And I thought so K-map is easy. That's why I did this one in the K-map. Fine, I will do K-map also. Don't worry. Right. Yeah, take this thing counters now here. We have so two types of counters, synchronous counter, asynchronous counters. We have two counters, and इसमें binary and non-binary counters. Binary में we have two categories. We have up and down counters. Up and down counters. In case of synchronous counters, there is a fixed sequence is possible. Fixed sequence in the sense and 0, 1, 2, 3, 4 like this, or 10, 9, 8 like this. Only fixed sequence only. Random sequence is not possible in case of asynchronous counter. But a random sequence we can do by using synchronous में होगा. Okay. Next. Now let's talk about some basic terms in case of a counter. State. We use frequently we use the one word that is called state of a counter. State means what? Simply output. The output of a counter is called as a state. The output of a counter is called as state. For example, if you have taken one flip-flop I have taken, let us consider. Then what will be the possible outputs you tell me? If we have taken one flip-flop I have taken, what will be the possible output? You tell me now the output. It may be a 0 or it may be a 1. Output which is what, tell me now, it may be a 0 or it may be a 1. And if we have taken the two flip-flops are taken, you tell me now here what will be the possible outputs you see? Two flip-flops I have taken, what will be the possible outputs you tell me now here? That is Q1 and that is Q0. So possible values are 0, 0 and 0, 1, 1, 0 and 1, 1. So these are the 4 possible values. Okay. Now in case of a 2 flip-flops. Similarly, if we have taken 3 flip-flops, I have taken, you tell me now. I have taken 3 flip-flops, I have taken. Can you tell me now possible values now? In those cases, what will be the possible values now? I can take it as Q2, that is Q1, and this is Q0. Possible values are 0, 0, 0, and 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. So that means totally how many possible values you can see now here? 8 possible values are there now. Totally how many possible values you can find now here? 8 possible values are there. So from this we can generalize now here. So here in this case, how many possibilities now here? So that is 2 square. In this case, how many are now 2 cube? If we have taken n flip-flops, have taken. How many possible values, sir, tell me? The possible values are 2 power n. If we have taken n flip-flops, have taken. What will be the possible values, you tell me? 2 power n. Isn't it? For in case of a n-bit counter, the maximum possible states are how many? 2 power n. Right. And so the states which are counted by the counter, that states are called as valid states. The states which are counted by my counter, that is called as a valid state. And which are skipped by the counter is called invalid. So that means I have taken 3 flip-flops, I have taken. Consider 3 flip-flops I have taken. Possible values are how many? So that means 8 possible values. Let us say first we have a 0. 0 के बाद I got 1. 1 के बाद I got 2. And 2 के बाद I got 3. And 3 के बाद I got 4. And the 4 के बाद I got 0. That means what happened, you tell me now. Actually, when you have taken 3 flip-flops, up to we can say possible values are what, tell me now, 0 to 7 tak possibilities. Yes or no? But my counter is counting up to 4 only. That means what we can say now here, this is 5, 6, 7. These are skipped now. These states are skipped, right? So these states are skipped. Yes, skipped states. Isn't it? These states are skipped states. These skipped states are called as a invalid states. And the states, these only my counter is showing now. These are called as a valid states. Okay. Next one. Binary and non-binary counter. Binary counter or non-binary counter. Binary counter means if the counter count all possible states, then that is called as a binary counter. If any skipped states are there, that is a non-binary. If any of the states are skipped my counter, then we can call that as a non-binary counter. Okay. Next. Now we'll frequently use the word of modulus of a counter. But the modulus of a counter means what? Tell me now. how many clocks required so that the pattern will repeat. The same pattern will come again. That is called as a modulus of a counter. So for example, if you take this example here, in this case, what we do is whenever they given a binary number, first you convert into decimal form, then we can easily identify the mod number. So here this is what is first number, this is 0. After 0 they are giving it as 1. Thereafter this is 2. Thereafter this is given as 3. And after that we have 0. Thereafter 1. This is 2. And this is 3. Like that it is proceeding now. You see this thing, wherever we have started, we need to come back to same thing, we have to come back here. This is one set I can say. To come to this thing, how many clocks required, you see this thing here first of all. So now from here to here, 1 clock required. Again from here to here, another clock. So here to here and here to here. So we have 1, 2, 3, 4. How many clocks required wherever we started? We have to come back to same state now. 4 clocks are required. So what I can say now, this mod number, from this mod number which is equal to 4. Okay. Right. Next, now you tell me the mod number here. Not one number, complete pattern has to repeat. Complete full pattern has to repeat again. So now in this case, you see this thing, this is 0 and 0 to 0. Next, after that we have 1. Next we have 1. No, this is 2, no, sorry. 2, this is 2. Thereafter we have 1. Thereafter we have 1. Now we have, this is 3. Next we have a 3. Next we have a 0. Next we have a 0. Next we have a 2. Next we have a 2. Next we have 1, like this happening now. Can you tell me now mod number here in this case? So here can you say this itself is a mod number? No, it is only the 0 0 repeated, not complete pattern now. This is not a mod number. So wait is started now here. Start here now. Similar pattern has to come back again here. So how many you can see now? 1, 2, 3, 4, 5, 6, 7, 8. So in this case, so how many, what is the mod number you tell me now here? 8 is a mod number. Okay. Huh? 8 is a mod number. So earlier there is no repeated states, but here the repeated states are there now. Repeated states are there. You have to, until you have to come back to the same state, we need to keep on, will continue. Okay. Next. Now try this one. What is the mod number? And we have, first we have a 0. 0 के बाद we have 1. 1 के बाद we have 0. And 0 के बाद we have a 2. And 2 के बाद we have 0. 0 के बाद we have 3. And 3 के बाद we have 0. 0 के बाद we have 1. That is 0 and that is 2 and that is 0 and that is 3. Okay, now tell me. And wherever we have started, we have to reach the same thing. That means what will be now 0 के बाद 1. Here 0 के बाद 2. This is not a pattern now. 0 के बाद 1. Yes, this is the pattern. So here this is one pattern. So now you can see now here 1, 2, 3, 4, 5, 6. So 6 clocks required. So from this what I can say now here mod number. From this mod number is 6. Okay. चलो now अभी ने हमने देखा you can see so design equation. So अगर if we have one flip flop is there, how many possible states you can see now? 2 states are possible and 2 flip flop either 4 states are possible and 3 flip flops either 8 states are possible. N flip flop either what are the maximum possible states you see? 2 power n states are possible ना. According ये हिसाब से हमने we need to select the number of flip flops required. If I say n is a mod number, if I say n is a mod number, so you can see now this mod number which is less than or equal to maximum possible states. Okay, if we are taking the log on both sides, then it will become as what tell me now here log 2 base n which is less than or equal to n, where this n is there a small n. Small n is the number of flip flops required. Okay. Next. So modern. So for example, if we have taken the time period of the input which is equal to t and frequency is a f. So the clock time period is t clock and this is f clock. So if it is a modern counter at the output may, so at the output the time period will becomes n into t clock. It will becomes what tell me n into t clock, f clock, it will becomes what tell me now here f clock by n. Time period is multiplied and frequency is divided. Time period is multiplied but frequency is divided. Okay, that's why this counters is also called it as a divided by frequency divider circuits, also called as frequency divider circuits. Now you can see here time period, if I say this as a t clock, here this is frequency is a f clock. Now you can tell me now here at the output time period is what I can say now, this is x into t clock. And here the frequency which is equal to what you tell me now f clock by x. Next here it will come it as xy into t clock. here f clock by xy, and here xyz into t clock, here f clock by xyz. Okay, frequency divider circuits. Done. Next, chalo, let us discuss about the asynchronous counter designing. Asynchronous counter designing. So you need to remember for designing of asynchronous counter some standard procedure you need to remember. So asynchronous, the name itself indicate means what? Tell me. Different flip-flop will respond differently. That means different clocks are given to the each flip-flop. We apply different clocks are given to each flip-flop. Asynchronous. There is no synchronization. And you need to remember one important thing is only one flip-flop we apply a clock signal. Only one flip-flop we apply external clock, and which are the flip-flop we apply the clock, that is LSB. Remember. Yes, which are the flip-flop we have given a clock, that flip-flop is a LSB. External clock flip-flop is a LSB, and from that we should able to identify MSB we can identify. And all the flip-flops are operated in toggle mode. All the flip-flops are operated in toggle mode. And there is a fixed sequence is there. Do remember here in this case, the sequence either is up sequence or down sequence. Means we have the sequence might be increasing manner or decreasing manner. So random sequence is not possible in case of a asynchronous counters. Okay. If it is a, consider if we have taken as a 3 flip-flops we have taken, and if it is an up counter, if it is an up counter, the possible, so this we can say Q2, Q1, and that is Q0. This possible values we can see it as what is now up counter. First it is 0 0 0. इसके बाद what will come here? Only 0 0 1 will come. There is no other alternative. Strictly this only will come. Next 0 1 0. 1 के बाद only 2 will come. Next 0 1 1 3 will come. Next 4 will come. Next 5 will come. Next 6 will come. Next 7 will come. Okay. Now if it is a down counter, so that is Q2, that is Q1, and this is Q0. If it is a down counter, so then the moment when you apply first clock, what will come here? It will come it as 1 1 1 will come, 7 maximum value. Thereafter will start decreasing. So this means 7. So thereafter will come it as what are we now? 6 will come. Next 5 will come. Next 4 will come. Next 3. Next 2. Next 1, next will come 0, 0, 0. So this is only the order can be possible, keep in mind. There is no other way can be happens. Okay, the order is strictly in this form only hoga. Understood what I am saying? Fixed sequence. Done? Now let's design this as up counter as well as a down counters. Look at here. So up counter, down counter, how we can decide? Listen carefully. So in case of negative edge triggered flip-flop, negative edge trigger, negative edge. So triggering, clock is a negative trigger and triggering, and Q we have given a clock signal we have given. Then that is up counter. Then that is what, tell me now, up counter. And so here, and how you can remember this thing here, you see this thing here. So as you might be know here, हमारा जीवन, how our life, you tell me now. हर जीवन में, so here it will be a combination of what is there, सुख and दुख. हाँ ना बोलो. So सुख and दुख we have. सुख and सुख के बाद दुख. Again thereafter we have a sukh. The process will keep on, will continue like this now. So here कभी सुख में हुआ तो इसके बाद दुख पर आएगा. हाँ ना बोल. इसके बाद अगेन वापस सुख पर आएगा. बोलिए. अगर आपने एंजॉय किया तो सो देन सो बाद में सो मेहनत तो करना पड़ेगा. इफ यू आर एंजॉयिंग नाउ देन यू हैव टू फेस इट नाउ. किया अगर आपने अच्छा प्रिपरेशन की, हार्ड वर्क किया, इसके बाद आपको सुख मिलेगा. Isn't it? हर जीवन में ये दोनों चलेगा ना. बोलिए. सुख और दुख अल्टरनेटिवली विल कम हियर. कभी टाइम सुख होगा, इसके बाद दुख आएगा. ये प्रोसेस तो कंटिन्यू होगा ना हमारा जिंदगी में. हाँ ना बोलिए. राइट. ये बात भी ध्यान दो आप सभी ने. ओके, सो यू टेल मी नाउ. अगर मैंने, सो हियर क्लॉक, so here we have given as negative edge trigger, we have given that is minus, and what is the clock, you tell me now. Q is given as clock now. If we multiply these two, what I will get, you tell me. What will get, you tell me now. Minus Q will come. Hana bol. Minus Q means now abhi this is in what is the state, you tell me now. Sukh position या दुख position. Now that is in दुख में आई ना. दुख आए तो दुख के बाद क्या आएगा? दुख के बाद क्या आएगा? सुख आएगा ना. So that's why this is up counter. सुनिए ये चीज ध्यान दो. So here minus Q, minus into Q will get minus Q ना. Minus Q means what I mean now, दुख. दुख के बाद क्या आएगा? सुख आएगा ना. That means that is the sukh mean that is up counter. Okay. Next here we have negative edge, that is minus. Next this is Q bar as a clock. ऊपर बार है ना. ऊपर बार we can side में रखो. Then what I will get, a minus into minus will become plus. Will get plus Q will come na. Plus Q आई तो this is in कौन सा state, you tell me now. सुख या दुख में? This is अभी this is सुख में आई ना. अगर सुख में आई तो सुख के बाद क्या आएगा? सुख में है तो आगे, अभी आपने सुख में है तो सुख के बाद क्या आएगा, दुख आएगा ना, दैट्स व्हाई इट इज अ डाउन काउंटर। ये बात समझ में आया सभी को? बोल। Next, here you can see now this is the positive edge trigger and Q as a clock. So that means what I can say now, positive means plus and clock is Q now. That means if we multiply, what I will get now, plus Q will come. Plus Q means this is कौन सा state? सुख का ही ना, सुख के बाद क्या आएगा, सुख के बाद तो दुख आना पड़ेगा, सुख के बाद दुख आएगा, so that is down counter. Now positive edge my Q bar, that means positive trigger and clock is what tell me now, minus Q. So that is what I will get to tell me now, minus Q now here. Minus Q I thought that is what tell me now here. This is दुख है ना, अभी अभी दुख है तो दुख के बाद क्या आएगा, सुख आएगा. So that's why this is up counter. ये बात तो समझ में आया कि नहीं सभी को? बोल। अगर ये चीज पसंद आई तो सभी ने दिल बना लो. चलो, now we'll start implementing the circuits, up counters and down counters. Now take this thing here. 3-bit ripple up counter. Ripple up counter. Okay, first of all, so you see this thing here. I need the 3-bit counter. So how many flip-flops are required, you tell me? How many flip-flops are required? Number of bits. One flip-flop can store 1 bit. I need 3 bits now. So that's why how many flip-flops required? We required 3 flip-flops are required. So 3 flip-flops we have taken. First to choose, we have taken 3 flip-flops. Okay. And so here I am calling these flip-flops, and all the flip-flops must be in what, tell me now, because ripple counter में toggle mode में होना पड़ेगा. Toggle mode. I am taking a T flip-flop. I am taking here T2 and this I am calling it as Q2. I am taking the T flip-flop. So this is Q0 I am calling, and this is Q0 bar, and this is T1, Q1 and Q1 bar, T2 and Q2, Q2 bar. All the flip-flops are in toggle mode na, ripple counter mein, asynchronous mein. So toggle mode, remember the 7 toggle mode we have discussed previously. 7 toggle mode. In T flip-flop, for the toggle mode, you tell me now input equal to 1. So I made this input equal to 1, 1 I made. Okay. And thereafter we need to apply the 1 clock. Ripple is different, toggle is different. Ripple is different. Ripples means what? What we can say now? So see, ripples are there now, like a waves. Those are called as ripples. Sea ripples. Okay. Those are the ripples. The waves will be formed now. Those are called as ripples. Okay. Toggle means changing. That is different. Now, T flip-flop, we have operated the flip-flops in toggle mode, first thing. and thereafter we need to apply the clock for one flip-flop. One flip-flop we need to apply here. You tell me now which clock, which whatever trigger you want to take. Positive edge trigger, negative edge trigger you want to take. Positive edge trigger you want to take, or negative edge trigger you want to take. So let us say you have taken a positive edge trigger. This is the way we can represent the positive edge trigger now. Now you tell me now, I need what counter I need now here? Up counter. Up counter के लिए, so positive edge trigger means what is the clock कहाँ से देना पड़ेगा? We have given this as what will be a positive edge trigger now. All the flip flops are positive edge trigger only. Tell me now here how the flip flops has been given. How the flip flop what clock has to be given? Q से Q bar से. Clock has to be given from where यार Q से देना पड़ेगा, Q bar से देना पड़ेगा. अगर आपने Q से दिया तो that means what element of Q into what element of positive edge trigger. So this is plus. It will becomes what element plus Q बनेगा ना. So ये down counter बनेगा. So but लेकिन Q bar से दिया तो it is up counter बनेगा. ऐसा देना पड़ेगा. समझ में आया कि नहीं बोल? Everybody. That's it. Now this is a 3-bit ripple up counter. If I simply leave this thing here, this counter will count from where to where now. First 0 will come, 0 के बाद will come 1, 1 के बाद it will come 2, and 2 के बाद 3 will come, 3 के बाद 4, and 4 के बाद 5, 5 के बाद 6, 6 के बाद 7, 7 के बाद वापस 0 बनेगा. बस. That is a counter. This is a 3-bit ripple up counter. Done. Now let's see now 3-bit ripple down counter. How we can design it? So 3-bit, so 3 flip-flops we have taken. 3 flip-flops, and ripple counter, all the flip-flops must be in toggle mode. So I have taken T0, Q0 and Q0 bar. So T1, Q1, Q1 bar, T2, Q2, Q2 bar. Now, what type of trigger you want to take? You tell me now. All are in toggle mode only now. So you tell me now. I am giving the positive trigger, positive edge trigger for all the flip flops. Okay. Positive edge trigger only I am taking here also positive edge trigger. अभी बोलो क्लॉक कहां से देना पड़ेगा ना. अभी क्लॉक कहां से देना पड़ेगा इधर? अभी Q से Q बार से देना पड़ेगा. हाँ यस. कहां से देना पड़ेगा? Q से देना पड़ेगा. अगर Q बार से दिया तो it will becomes what? Tell me now. If I given the Q bar, it will become up counter, but we need down counters now, so we should give this as कहां से Q से देना पड़ेगा. बस. And if we did it now here, it will behave like a. So here down counter. The counter will keep on, will count from where to where now here. Starting 7 will come. 7 के बाद it is 6. 6 के बाद 5. 5 के बाद 4. 4 के बाद 3. And 3 के बाद 2. 2 के बाद 1. 1 के बाद 0. And 0 के बाद 7 will come. This is the process. Okay. Done. Next, now you can see now here 3-bit ripple up या down counter. It should behave like a up counter जैसा and down counter जैसा दोनों काम करना पड़ेगा. How we can achieve this thing? How we can design this thing? Tell me. In this up and down counter, what the difference you see this thing? This clock only, remaining everything is same only ना. अगर up counter तो Q bar से देना and down counter है तो Q से देना. Okay, so that we should implement it now here. Look at now. 3-bit, so I have taken 3 flip-flops. And here you can see now this is T0, Q0, Q0 bar, T1, Q1, Q1 bar. So this is T2, Q2, Q2 bar. So I am using a positive trigger only I am taking. Even if you want, you can go for negative trigger also, accordingly will changes. I am going for positive trigger. Okay, fine. All the flip-flops in toggle mode. 1 flip-flops in toggle mode. Fine. तो अभी इधर ध्यान देना पड़ेगा, इधर क्लॉक अप के लिए क्लॉक कहाँ से आना पड़ेगा? क्यू बार से. डाउन के लिए क्यू से देना पड़ेगा. सो हाउ वी कैन डू इट नाउ हियर? इसके लिए हमने कभी कभी टाइम इधर क्यू जाना पड़ेगा, कभी कभी टाइम क्यू बार जाना पड़ेगा. इसके लिए हमने एक मामा जी का हेल्प ले लिया. ये मामा जी कौन है? मामा जी का हेल्प ले लो. ये मामा जी कौन है? हाँ, मामा जी कौन है? So this is 2x1 mux हमने ले लिया. Okay, this is the selection line. Yeah, this is 0, this is 1. Here this is output y. And these are connected here like this. And this is 0, this is 1, this is 2x1 mux. And this is y. And here is the selection line. Now here this is the selection line S. Okay. And so this output is given as clock. You see this thing here. If I given let us say S is equal to 0 given. You tell me now what is the output पर क्या आएगा? Q आएगा, Q बार आएगा, Q नॉट बार आएगा. 0 दिया तो then what will come this output पर? So this is Q naught आएगा ना. Here this is Q1 आएगा. That means this is what type of counter होगा? You tell me now. Up या down counter? This is what tell me now here. Then it is down counter. खाना बोलिए. अगर if I given S is equal to 1, tell me what happens. S is equal to 1, what happens? Then output पर क्या आएगा here? Q bar आएगा, Q naught bar आएगा. So then it will becomes what tell me now? Up counter. Understood? You tell me. Yes, ये logic हम use करेगा. Whenever you need to design both and up and down, if you want, we can use this logic. Done. Yes. Next. Now, so here अभी तक so we have designed the asynchronous counters. ये बात आपको समझ में आया होगा, I think so. Now we are using some additional things now here. Asynchronous clear and asynchronous preset. These are the two additional pins we use. So in this case, previously अगर आपने ध्यान से देखा तो इसमें this is the up counter. This counter will count from where to where now 0 to 7 तक continue करेगा. But लेकिन अगर हमको केवल 0 to 4 तक चाहिए, 5, 6, 7 not required. Yes, up to 4 is required. 4 के बाद वापस 0 चाहिए मुझे. In those cases, we need to use some additional pins. हम use करना पड़ेगा. Those additional pins are called as a clear and preset. By using these two additional pins, let's see how we can use these additional pins to design the counters. Look at now, this clear and preset, these are what type of pins? We can say overwriting pins. Means if I say this is clear pin is activated, this is clear pin is activated, irrespective of the state of the flip-flop, it will immediately make the output of the flip-flop as what terminal 0 the moment clear pin is activated. Okay, this is clear bar now. So clear bar is 0 means clear is activated. Agar clear is activated, it doesn't see clear bar is 0 means clear is 1. Okay, here this is what we can say now. Sometimes they will use it as bubble now. Clear bar is 0. That means how much the clear value which is equal to 1. Clear pin is activated. So that means the flip-flop will be resetted completely. Okay. And here preset, when the preset is activated, it doesn't see the output now here. It will make this value as 1. It will set the output. Preset is 1. If the preset bar is 0, preset bar which is 0 means preset equal to 1. If the preset is 1, it will set the flip-flop. Right? Copy this thing, all of you. Now let's see by using these two pins how we can design the counters. Take this one here. Yes, the moment if the preset is 0, clear is 0, that means the flip-flop will continue as usual, its operation continue karega. then we can call this is what, tell me now here, normal operation, that is called as a clocked operation. Normal operation it will continue karega. If the preset is 0, clear is 1, that means which pin is activated? Clear pin is active. The moment clear pin is activated, output of the flip-flop will become 0. And if it is 1 and 0, which is active now here? Preset is active. Then it will becomes what, tell me, 1. The moment both are 1, क्या होगा? अगर both pins if we press, then it will becomes invalid. ये पागल बनेगा ना? अगर दोनों प्रेस किया तो क्या होगा? पागल हो जाएगा. Now take this one here. Design a mod 6 up counter. First of all, you tell me now how many flip-flops we require. Mod 6 means we need to have 6 states are required. Okay. Mod 6 up counter के लिए how many flip-flops required? You tell me first of all. How many flip-flops required? Yes, 2 flip-flops chalega? No. So minimum 3 flip-flops are required. Right. So 3 flip-flops. We'll take the 3 flip-flops. So this is T naught, Q naught, Q naught bar, T1, Q1, Q1 bar, T2, Q2, Q2 bar. All the flip-flops are in toggle mode like this. And what type of clock you want to give, you tell me now? Yes, we need up counter now. So here I am giving. So if I given a positive trigger, so then clock कहाँ से देना पड़ेगा? Q से, Q बाद से. From where we need to give the clock now? कहाँ से? Q से, Q बाद से. It's a up counter ना. So we need to give the clock from where, you tell me now? Q बाद से देना पड़ेगा. Q बाद से दिया. बस. Okay. Now it is a up counter. So if I leave like this counter will keep on, will count from 0 to 7, 0 to 7, 0 to 7, continue karega. But lekin they given it as what, tell me now? Only, so here 0 to 7, how many states are there? 8 states are there, but they are saying it as only mod 6 counter only. That means they need only the 6 states only required. Yes or no? They need only 6 states. Means first we have tell me up counter 0 0 0. First we need 0 required. 0 के बाद 1, 1 के बाद we have 2, 2 के बाद we have 3, 3 के बाद 4, 4 के बाद 5. How many states? 1, 2, 3, 4, 5, 6 states. Now 5 के बाद what we required now here? 5 के बाद again we need 0 required. Yes sir, now 5 के बाद we require 0. But लेकिन what is actually what happens now? 5 के बाद क्या आएगा? If I leave like this, 5 के बाद we'll get a 6 will come ना. So 6 नहीं चाहिए हमको. We no need of 6 ना. The moment when you got the 6, now immediately we need to clear the output. We need to clear the output. Clear करना पड़ेगा. इसके लिए हमने what we are doing here, you see this thing. For that purpose, I am doing it as 6. The moment we got the 6, 6 means what, tell me now here? 1 1 0. That is what, tell me now here? Here this is external clock now. So this is LSB. This is LSB and this is MSB. So this is Q2, Q1 and this is 0 now. So I can say Q0 bar I can say. So what will be the clear bar? You tell clear pin now tell me. Which is equal to what? Tell me now Q2, that is Q1 and that is Q0 bar. So what I do here, I have taken one AND gate, I have taken one AND gate. This AND gate is connected here. AND gate is connected here. And the inputs we can see now, this is what I will now Q2, this is Q1 and this is Q0 bar. Okay, and this is a clear. Understood now? Tell me. बोलिए now here this thing. Now this is the mod 6 सब काउंटर बनेगा इससे. Right? Next, now see this thing. Next one, mod 6 down counter. First design a counter, 0 to 7 counter. As usual, first we will design a counter which will count from 0 to 7 continuously, and sorry, down counter now 7 to 0. And thereafter we need to use the preset I use here. Now, so this is T0 and Q0, Q0 bar, T1, Q1, Q1 bar. Last when we did that to remove 6. Exactly, 6 is not required. So here mod 6 means कहाँ से up counter ना, but states required you tell me now 0, 0 के बाद 1, 1 के बाद we need 2, 2 के बाद we have 3, and 3 के बाद 4, 4 के बाद 5, and yes, now we don't want any other states. The moment we got the 5, 6 we 5 we got, 5 के बाद 6 will come now. The moment we got the 6 has to, all the flip flop has to become 0 0. So all the flip flops, so this value has to become 0, this value 0, this value 0. The moment it is 0, now we'll reach to here now. If I reach now, again this loop will continue. Okay. So here will come it as Q0 will come. This is Q1 and this is Q2 will come. The moment, so 5 is, no, 6 is not required. The moment we got the 6, now immediately all the flip-flop has to become 0 0 zeros. Then if it is once become 0 0, again will become 1 2 3 4 5 6 like that. 5. Again 5, 6, the moment we got the 6, now immediately will be 0. And 6 is the meta stable state, which is it will come and will go. It will just blink like that. Next, so this is T2, Q2 and this is Q2 bar. All the flip-flops are in toggle mode now first. Fine. Next, what clock you want to give? Tell me now. Positive trigger I am giving. Even if you want, you give the negative trigger also. Then according to that will changes. Now you tell me now we need what counter? First of all, you tell me now down counter. Down counter के लिए clock कहाँ से देना पड़ेगा? डाउन काउंटर के लिए क्लॉक कहाँ से देना पड़ेगा? क्यू से देना पड़ेगा, इसीलिए क्यू से क्लॉक दिया मैंने. So this is a counter. This counter will count from way to way 720 कंटिन्यू करेगा. सो बट लेकिन हमको क्या कितना स्टेट चाहिए? ओनली 6 इज रिक्वायर्ड. फर्स्ट वी हैव 7, 7 के बाद वी हैव 6, 6 के बाद वी हैव ए 5, 5 के बाद 4, 4 के बाद 3, 3 के बाद वी गॉट 2. 6 स्टेट्स हो गया ना. सो हियर दैट मीन्स अभी तो हमने क्या करना पड़ेगा? So here the moment we got the 2, so thereafter we need 7 only required. But basically 2 के बाद क्या आएगा? 1 will come ना. 1 means what I can, how I can write? 1 means how we can write now here? 0, 0, 1. 0, 0, 1 हमको नहीं चाहिए. So that's why what I can say now, this is Q2 bar. This is Q1 bar. And this is what, tell me now, Q0. Okay. Yes. So then here I have taken one preset. I have taken preset, PRE, preset, PRE, preset I have taken. And I have taken one AND gate. Connected like this. And the inputs for this AND gate you see. And what are the inputs for AND gate you tell me now? We have Q2 bar dena padega here, Q2 bar. And that is Q1 bar. And that is Q0. ओके, हो जाएगा. चेक करो. Attend. Okay. Next one. Now try this thing. Modify up counter. Done this one. Up counter. The condition here is the flip-flops are in toggle mode. Okay. So that's why I'm taking it as T flip-flop. I'm taking easily. Okay. Even you can use other flip-flop also. But the condition is the flip-flop must be in toggle mode. T is equal to 1 directly. And I given this as positive edge only. I have given clock. First we need to make it as up counter. Up counter के लिए we have given a clock. यहाँ से देना पड़ेगा. Yes, we have given clock Q bar से. Okay. Thereafter we should make it as what element of here. So reset करना पड़ेगा. Up counter के लिए first states require terminal 0, 0 के बाद we need 1, 1 के बाद 2 and 2 के बाद 3, 3 के बाद 4, 1, 2, 3, 4, 5 states are there now. 4 के बाद we required 0 required, 5 not required, isn't it? 5 को remove करना पड़ेगा. The moment we got the 5 has to be reset करना पड़ेगा. That means what element of 5 means 1, 0, 1. That means what I can say Q2, Q1 bar, and this is Q0. Yes, so I have taken clear pin. I have taken clear pin. And I have taken one AND gate here also. AND gate output is connected here. And inputs for AND gate, that is what I know Q2, that is Q1 bar, and that is Q0. Done. This is the way. Okay. Like this you can able to design the OR circuit now. Toggle means change. First 0, next 1, 0, 1, 0, 1 has to become like that. It has to change from values now. First 0, next 1, 0, 1, 0, 1 like that. If we have, that is called as toggle mode. Next. And delay analysis. In case of a asynchronous counter, if the delay of each flip-flop is TPD, the overall delay is what we can say? N into TPD. So each flip-flop will have a delay of 1 TPD. Now. Next it will keep on, the delay will be propagated. So it will becomes N into TPD. Okay. And the time period of a clock signal हमने कितना देना पड़ेगा हमेशा? So greater than delay. एक बार all the flip flop respond करने के बाद next clock we have to give. We need to wait until all the flip flop will use the output. Okay. Next. Yeah, take this problem. Yeah, first of all, you tell me now what is the mod number? Hmm? Huh? Tell me now, first of all, mod number. This is what counter? Synchronous or asynchronous counter? So here you see this thing, clock is positive trigger na, and clock is given from 𝐂𝐨𝐬𝐬. So that means different clock. So this is what counter? First of all, asynchronous counter. This is asynchronous. And up or down counter? Down counter na, tell me all of you. Asynchronous down counter. Okay. Now tell me. And so this is, there is no reset logic, isn't it? So can you tell me the mod number? So we are just leaving the counter now. If I leave now, it will count from way to way. Now 720, 720 will keep on, will count. And which is equal to mod 8 counter. So the JK flip-flop they have taken. J is equal to 1, K is equal to 1. That is also toggle only na. This is the toggle nature of a JK flip-flop. So the mod number is 7. Okay. Next, they given as output frequency of the counter. If the input frequency given as how much? 10 mega. So that means what is the output frequency? Tell me. So the frequency of output, which is equal to what I will get, tell me now, f clock by mod number. F clock by mod number. How much will come f clock? That is 10 mega by 8 na. So tell me now here how much f clock? 10 mega. So by mod number is 8. So this will become 5 by 4. So will come it as what will be now 1.25 megahertz. No, we should not eliminate na all these things. So we'll count. We don't eliminate 7 na. It will count from way to way now. 7 also concluded. Included 7 to 0 will count na. Mod 8, not 7. If the delay of each flip-flop is 50 nanosecond, maximum frequency of the clock is. Then what is the overall delay, you tell me now? So the C bit delay of each flip-flop is given as 1 clock. The overall delay is how much? Overall delay, which is equal to what we can say now? N into TPD. So we have 3 flip-flops are there. 3 into TPD. Delay of each flip-flop is 50 nanoseconds. 50 into 10 power minus 9. Now this is time period of a clock signal. It must be greater than T delay. So that means how much it is? 150 into 10 power minus 9. So that means frequency of a clock is less than or equal to 1 by 150 into 10 power 9 minus 9. This will come to be a what, tell me now? This maximum. So we can say this as maximum clock frequency. So this is f clock, which is equal to 10 power 9 by 150. How much this value will come? So this is 10 power 8 by 15. How much this clock frequency, tell me? How much this value? Yes, so this value is 6.67 mega. Check it, all of you. State of counter after 400 clock pulse, the initial state is given as this much. Now here they are asking to find out what will be the state of counter after 500 clock pulse. Now what the pattern of a counter, you tell me now here. So we have this counter, this pattern, which is the pattern is like this. So if I say this is my clock, now we have this is Q2, Q1, this is Q0. 1, 2, 3, 4. So the 0, 1, 2, 3, 4, 5, 6, 7, 8. Now this pattern, initially they given this value given as what initially here. They given this value as what, tell me now, this is the pattern will come. Basically. We no need of this thing at all. And this counter this value, so this is Q2, Q1, this is Q0. Okay, these values. Now they given this mod number is how much they given? Mod number which we have this as 8 now. Now they given the 100 clock pulse, 500 clock pulse. 500 clock pulse means we'll divide with the 400 with the mod number. How much will come here? 8648 now. So this is 20. So 216. Then we'll get a remainder is 4 will come. Okay. That means what we can say now here, initially what the state they given? Initially they given 0th clock pulse. Initial state which is given as 100 given na. How much the initial state is at this much. Then what will be the 8th clock pulse? 8th clock pulse, the state value again will repeat na. That means 8 into 1. Next, can you tell me now 8 into 2 how much will come? That also will come the same thing only like this. And this 500, how we can write the 500 to tell me now? 8 into 62 plus 4 I can write now. 500 we can write as 8 into 62. So means what is 8 into 62. This process will keep on, will continue. Now tell me now 8 into 62. What will come? You tell me now. Again same value will come. Now after that we need 8 into 62 plus 1 plus 2 plus 3 plus 4. We need this value. And this is what counter? You tell me now. Up counter na. Up counter. So we have this is what, tell me now, 4 is there. That means here we should get 3. Here we should get 2. Here we'll get it as 1. Here we'll get 0 now. 0 means 0, 0, 0. So that means what we can say now, at the 400 clock, what happened? You tell me now here. We'll get this value as 0, 0, 0. समझ में आया कि बोल? Completed? Next. So now let's talk about the next one, synchronous counters. And I think all of you know how to get the notes. I think all of you got the notes now. You do message me in the Telegram. You do message me in the Telegram, so you will get the link. With that, you can join the WhatsApp group. You join the WhatsApp group, and there in the description you will get the notes will come. Not only digital, I think so. You will get the all subject notes. उधर आपको मिलेगा. Okay, and do message me in the Telegram. Synchronous counter. See this thing. And here we are going to discuss our three special counter, that is what element. One is a ring counter, Johnson counter, and user defined counter. Ring counter, Johnson counter, these are fixed counters. User defined counter means whatever the sequence we required, we should develop the required sequence. Okay, let's see one by one. So this is the 4-bit ring counter. 4-bit ring counter. This is similar to like a shift register. In case of a shift register, the output will be simply left. But here, what we did now here, the last flip-flop output which is connected back to the first flip-flop. This is the shift register. Okay. And the block diagram analysis, if we observe here like this. This is the block diagram analysis. Now initially, so here let us consider when the clock is 0. Let us say here this initially 0, 0, 0, 1. When you apply first clock, this 1 will come to here. So you can observe now this feedback. So you can see now last flip-flop, which is again come back to the first flip-flop. Okay. So it will come like this. Now this 1 will come to here 1. Now this 0 will be shifted here like this, and 0 and this 0 like this, similar to like a right shift register. Now the 0 second clock when you apply, so the 0 will come here. This is 1, 0, 0, and third clock 0, 0, 1, 0. Fourth clock 0, 0, 0, 1. This is the process. Okay. When you apply fifth clock, what happens now? Again 1, 0, 0, 0. Sixth clock 0, 1, 0, 0. Seventh clock 0, 0, 1, 0. Eighth clock 0, 0, 0, 1. Like this process will keep on, will continue. So you see this thing here, this whatever the state is there, same state has been repeated here now. So we can say mod number is how much, you tell me in this case? 4. In this case, mod number is how much, you tell me now? 4. Okay. And you can see the state diagram. What are the states are there, you see? Now here we have initially, if we talk about this one, What is this value now? Tell me now. Initially 0, 0, 0, 1. Next 1, 0, 0, 0. 0, 1, 0, 0. 0, 1, sorry, 0, 0, 1, 0. The states are coming like this. Okay. This is the state diagram. And if we observe the pattern, what we are getting, you see, in this case. And so when you apply the clock 1, 2, 3, see this thing 1, 2, 3, 4. So here Q0. What is the Q0 pattern you observe? Q0 pattern. Here this thing now like this. We have 1, Q0 pattern. So which is 1, 0, 0, 0. Next Q1 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So you can see here this pattern you can observe 0, 1, 0, 0. 0, 0, 1, 0. 0, 0, 0, 1. Okay. And what is the time period? You see this thing 4. Time period is 4 times of T clock. And frequency F clock by 4. And duty cycle how many times is 1? Only 1 time. So that is 1 by 4 into 100. So that means how much we can say now? 25%. Here also 4 times of T clock now. And this is F clock by 4. And this is duty cycle is 25%. This is also 4 times of T clock time period. And this is F clock by 4. 25%. 4 times of T clock. So that is F clock by 4. And this is 25%. Okay. Now you see, for in case of 4-bit counter, what we have seen now, tell me how many used states you tell me now? The number of used states are 4. Only 4 are used states. Isn't it? We have, that means we write in the numbers now, we can write as, so initially 0, 0, 0, 1. 1, 0, 0, 0. Next 0, 1, 0, 0. Next 0, 0, 1, 0. Tell me used states we have 1 comma, we have 2 comma, 4 comma, 8. Unused states are what you tell me now? So 0, 1, 2, 3, 4 is there. So now 5. Next 6, 7, 9, 10, 11, 12, 13, 14, 15. These are unused states. And then T clock, if it is a time period is a T clock, frequency is a F clock. What will happen now here? So the time period n bit case, so this is n into T clock. And this is frequency F clock by n. Okay. Phase shift between successive waveforms. In case of n bit case, which is equal to 360 by n. If the delay of each flip-flop is TPD, then overall delay, which is equal to, so this is what each flip-flop delay is T. So synchronous counter, all the flip-flop will work simultaneously. So the delay is TPD. If one flip-flop has a maximum different delays, then which I can say, so max of TPD, whichever having a maximum, that delay has to be considered. Okay. La 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 la. This is a ring counter. Advantage is what I'll be now designing is easy. The problem is, so you see this thing here in this case, initially what is the flip-flops we have taken, you tell me now? The flip-flop 0, 0, 1 we have taken. If all the flip-flop values are 0, 0, 0, then the counter does not start. Isn't it? Always 0, 0, 0 only, na? If the initial state is 0, 0, 0 हुआ तो क्या होगा? You tell me now. Initial state is 0, 0, 0, 0. Even if you apply any number of clocks, always 0, 0, 0 only, na? The counter does not start. So this problem is called a starting problem. And the other thing is, by mistake, if the because of the any problem, if it is entered into any of the unused state, it will permanently stay in the unused state only. It does not come back to used states. So that is another problem. This problem is called as a lockout problem. Okay. Next, Johnson ring counter. So earlier the ring counter we have connected. So here Q say we have connected, but here Q bar say has to be connected. Remember, that's why this is called as twisted counter. Okay, this is a Johnson ring counter. If you see the block diagram, you can observe here. Earlier you can see only there is a NOT gate. But so earlier there is no NOT gate. Now here we have NOT gate is present. Earlier the output is directly we have connected, but here is a NOT gate is present here. Okay. Now if the clock is 0, let us say initially these values are, all the values are 0, 0, 0 initially. When you apply clocks now here, so NOT gate now it will becomes 1, 0, 0, 0. Second clock when you apply 1, 1, 0, 0. Third clock 1, 1, 1, 0. Fourth clock 1, 1, 1, 1. Fifth clock 0, 1, 1, 1. Sixth clock 0, 0, 1, 1. Seventh clock 0, 0, 0, 1. Eighth clock 0, 0, 0, 0. Like, okay. Now here you can observe the things now here initially. Yes, now here initially all values are 0, 0, 0. So see the pattern how it is happened now here. Initially all the values are 0, 0, 0, 0. Next 1, 0, 0, 0. Next 1, 1, 0, 0. 1, 1, 1, 0. Next 1, 1, 1, 1. So 0, 1, 1, 1. 0, 0, 1, 1. 0, 0, 0, 1. This is the pattern happen now. In this case. Done. Next, if we see the repeating patterns, so clock 1, 2, 3, 4, 5, 6, 7, 8. Now you tell me now pattern what we have. These values you can see. This is the values you can see now. This is 0, 0. Yes, 1, 1, 1, 1, 0. Check it. This is Q3. Next, this is Q0. So this is Q1, Q2 pattern you see. Next here. So 1, 2, 3, 4, 5, 6, 7, 8 clocks. 2, 3, 4, 5, 6, 7, 8. After 8 again will be repeat hoga pattern. So you can see these patterns now here. 0, 0, 1, 1, 1, 1, 0, 0. So 0, 1, 1, 1, 1, 0, 0, 0. 1, 1, 1, 1. So 0, 0, 0, 0. So you can tell me now here. Time period is how much? 8 into T clock. Frequency, mod number is 8 now, so F clock by 8. Duty cycle is 4 times is on, 4 times is off. So the duty cycle is 50%. So this is 8 into T clock. So that is F clock by 8. So this is 50%. 8 into T clock. F clock by 8. So this is 50%. 8 into T clock. That is F clock by 8. And this is 50%. Okay. All of you do like the session and share to all your friends. Now you tell me now here in this case, 4-bit Johnson counter, used state. What are used state and unused state? Used states are what we have, tell me. We can say now 0, 0, 0, 0. Next 1, 0, 0, 0. Next 1, 1, 0, 0. 1, 1, 1, 0. 1, 1, 1, 1. Next 0, 1, 1, 1. 0, 0, 1, 1. 0, 0, 0, 1. 0, 0. Like this will happen now. So you tell me now, this is 0 we have, this is 8, 12, this is and 14 now here. So this is 15, 7, this is 3, this is 1, 0. Tell me now here we have 0, comma, 1, comma, yes, 3, 7, 8, okay, 12, 14 and 15. 8 used states are there now. And remaining are unused states. What are them here? 2, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Unused states. Mod number how much? 8. Frequency how much? F clock by 8. And in case of n-bit case, number of used states. How many? Tell me now here. 2n. Unused states. Total states are 2 power n. Used states are 2n. So total minus used states. And mod number is nothing but used states only, 2n. Frequency how much now? We can say f clock by 2 power 2n. Sorry, f clock by n. Next, now let's summarize the things now. Ring counter and Johnson ring counter. Summary, you can tell me. Mod number. So ring counter mod number is how much now? N. Johnson counter mod number is 2n. Used states are how many? N only. Unused states are 2 power n minus n. Here used states are 2 power n. Unused states are 2 power n minus 2n. Time period of each flip-flop is what I will know? N into t clock. And frequency is f clock by n. Here time period is what I will know? 2n into t clock. And this is f clock by 2 power n, and both will suffer from lockout problem. Both have a lockout problem, right? Next one, user defined counter. User defined counter means according to requirement of client we can design a counters according to requirement. That is called as user defined counter. Let's see this thing. Take this problem. Design a synchronous counter using whose counting sequence is this much using a T flip-flop. We need to design a one counting synchronous counter to have this much of pattern, right? So now you can see now they ask in a T flip-flop. So whenever you need to design a synchronous counter, we need to form a tabular form. We have to form like this. A tabular form is required. So this is what we can say now here, present state, and this is the next state and flip-flop outputs. So this is what will be now present state, and this is next state, and next one is a flip-flop inputs. Okay, so which we have this as Q1, and that is Q0. Next we have Q1 plus Q0 plus, and T flip-flop T1 and T0. Yeah, here you can see now here, if the present state which is equal to 0 0, इसका next state क्या है? This is the next state, that is 1 0. And if I say this is the present state 1 0, इसका next state क्या है? This is 0 1 is a next state. But this 0 1 is a present state, इसका next state is 1 1. 1 1 if the present state, इसका next state क्या है? This thing, that is what I mean 0 0. So here and here value same that we should write. Okay, this table you understood now first of all. Now we need to match with the excitation table. Here this is what flip-flop is given, T flip-flop. Now T flip-flop excitation equation I told you if you remember. Johnson counters are self-starting counters. Yeah, Johnson counters are self-starting counters. Yes. Now this is Q plus, which is equal to what? Tell me now. T XR with Q now. Same here. Abhi T is equal to Q XR with Q plus. Okay. Now you can see. Now this is this and this XR is what? Tell me now. This XR for these two. These two XR is what? Tell me now here, which we have 1. So this and this XR is 1. These two XR is 1. These two XR is 1. And this and this XR is 0. 0, 1 is 1. 1, 1 is 0. 1, 0 is 1. Okay. Understood this one? Tell me first of all. Now we need to write the equations we should write. Tell him the equation how we can write T1. T1 all are 1, all are min terms only 1. Whatever T0 equation you tell me now, these are the min terms now. In this case, Q1 Q0 bar plus Q1 Q0. So we can take out the Q1 common. So this is Q1. Done. Now finally we need to implement this one. How will implement it? You can see. We have taken the two T flip-flops. So this is T1, Q1, T1 bar, T0, Q0, Q0 bar. So here these are what type of counters are? Synchronous counters means same clock. Same clock is given to the both the flip-flops. Okay, same clock we have given, and we have given as a positive edge trigger. Next you see the inputs now. Q1 is given as 1. So the Q1 which is given as 1 and Q0 equal to Q1. Q0 equal to Q1. This connected like this. So then this is the counter will give the required desired output will come here. Okay. Done. Now take this pen. Find the counting sequence of the following. The initial state is given as like this. Then okay, find the counting sequence. Now earlier they given it as what? Tell me now. Here sequence is given. We have design, but here they given circuit is given. We need to find the what will be the state in the particular clock pulse. Okay. Now let's see this thing. In these cases, we need to form a tabular form like this. We need to form a tabular form like this. Here we know flip-flop inputs we know, and flip-flop inputs we know, we need to get the outputs we need to get. So that's why those things will write now here. Here we know flip-flop inputs now. So flip-flop inputs we have taken, and flip-flop inputs are, this is T1 which is given as 1 and T0 which is connected to what element of Q1, and here we have, this is Q1 plus and that is Q0 plus. Initial values given as 0 and this is 0. Okay. Now, so now you see the first one. So this is 1. T0 equal to Q1. Q1 means 0 now. If this is 1 given, what happened to response of this T flip-flop is a toggle nature. Toggle means previously 0, now it is 1 now. So T flip-flop 0 given, that is a hold state. Previously 0, now also 0 only. Next here, next one is what element of here? T1, 1, T0, Q1 is 1. 1 means toggle. 1 means toggle. Next, 1, Q1, 0. 1 means toggle. Toggle means this is 1. 0 means hold state. Next, this one, 1, Q1, that is 1. So this is toggle, this also toggle. We got the initial state we got now. So this is the state of the counting pattern. So that is, we are getting it as what element of 0. 0 के बाद we are getting it as what element of 0, 0. 0, 0 के बाद we are getting it as 1, 0. And 1, 0 के बाद we are getting it as 0, 1. 0, 1 के बाद we are getting 1, 1. Thereafter again 0, 0. Okay. Now see the things now in the problem. What they asking? They asking for 230 clock pulse, 236 clock pulse. What I should do here? 236. Now we'll divide this thing with a 236. But the mod number is how much now? 4 now. Mod number is how much here? 4. Mod number say we'll divide it. If I divide with this thing, how much will get the remainder? You tell me now. 236. So here 4 5 is 20 and this is 3 6. So 36 only na. So I will come 0. So that means what the state you can say now here in this, in the 236 clock pulse, how much this value? We'll get it as 0 0 only. Okay. Next, 251 divide with the 4, tell me the remainder. So here, so this is 1 1. So 2 8 and which is remainder is 3. So remainder is 3. So that means what is this value now? 251 clock pulse. We'll get this as what are we now? 0 1 2 3. So this is 1 1 will come. Okay. Next one. So here 4 divided with 333. So how much now here? 32. So will come 1 3. So this is 3 is 12 now. So this is 1. So that means what this value tell me now here? So this is after this is 1 0. See, 333 clocks. 333 clocks will come it as what tell me now? 1 0. So in this clock, what is the state value is 0 0. Here, this is what I'll be now 1 1. Here, this is what I'll be now 1 0. Okay. Hmm? Isn't it? Right. Fine. Okay, that's it for today with this. And so here next we have the FSM is left here. Finite state missions in the sequential part, and that part and data converters will finish. We'll see in and K-maths. These topics we'll do in the one short session. Okay. Fine. Okay then. See you.